So looking at your directions, it says use the table to create a graph of the parent square root function, then list the domain and range. So first you were supposed to plot the points. When you put in -1, it's an imaginary number, so it is undefined. It's undefined. When you put 0 in under the square root, it is 0. The square root of 1 is 1. The square root of 2 is approximately 1.41. The square root of 3 is approximately 1.73, and the square root of 4 is 2. So using the table, let's create the graph. So we have 0, 0. We have 1 and 1. We have 2 and 1.41. And we have 3 and 1.71, and we have 4 and 2. So it looks something like this. Cube root parent function, use the table, create a graph of the parent cube root function, then list the domain and range. So we have cube root of square root of 3. Sorry, cube root of -3. So that is approximately -1.44. And the cube root of -2 is approximately -1.26. Cube root of -1 is -1. Cube root of 0 is 0. Cube root of 1 is 1. Cube root of +2 is approximately 1.26 and 1.44. So graphing this, it looks something like this. We know it's 0, 0, 1 and 1, -1 and 1. So -3 and 1.44. And then 2, 1.26, and 1.44. So it looks something like this. So looking at the graphs, let's look at domain and range. So domain is all your x values. Range is all your y values. So our domain has to be, x has to be greater than or equal to 0, because otherwise it's undefined. So the y values, our output is going to be y is also greater than or equal to 0. Everything's going to be positive here. For your cube root, it looks like we can put in any number. So our domain is all reals, and then our output is also all reals. So that's what you should have seen on your first page. All right, now let's look at transformations. So we're starting with basic functions, cube roots or square roots. And we need to look at what if we add to it or subtract to it or multiply by something. So you have your transformations review sheet. We looked at these at the beginning of the year. It shows us how things move horizontally, vertically, if there's a reflection, if there's a stretch or a shrink. So we need to describe the transformation of f represented by g. So we see we have the square root of x as our parent, and we have square root of x minus 3, so this is like being in the parentheses. So that would be a horizontal translation. So it looks like this right here. So the -3 is your horizontal translation. Three units to the right. And the +4 is outside of the square root sign, so it looks like this. So that is a vertical translation. 4 units. So now we have f of x equals the cube root of x, and g of x equals the cube root of -8x. So we have under the square root sign, we have the -x. So when the negative is on the inside, we have a reflection in the y-axis. And then we have the 8. So when the 8 is on the inside, that is a horizontal shrink by 1/8. So remember this from a long time ago. When it's horizontal, it's 1/, whatever the factor is. The function e of d equals 0.25 times the square root of x approximates the number of seconds it takes a dropped object to fall d feet on Earth. The function m of d equals 1.6 times e of d approximates the number of seconds it takes a dropped object to fall d feet on Mars. Write a rule for m in terms of d. Then tell how long it takes a dropped object to fall 64 feet on Mars. So first thing, we're going to write a rule for m in terms of d. So we have e of d equals, we were given that up here, 0.25 times the square root of d. M of d equals 1.6 times e of d. So we're going to substitute e of d in. So we know what e of d is equal to. We're going to put this right here. So m of d equals 1.6 times 0.25 times the square root of d. If we simplify this, m of d equals 0.25 of 1.6 is 0.4 and the square root of d. So we wrote a rule for m in terms of d. So wrote the rule of m in terms of d. We took what we started with, the e of d. We took the function m of d, substituted the e of d in, simplified it. So our second part is to determine how long to fall 64 feet on Mars. So our D is our feet. So down here, our M of D is the feet, D is the feet on Mars. So we're going to substitute the 64 in for D. So M of 64 equals 0.4 times the square root of 64. So we have 0.4 times the square root of 64. We know the square root of 64 is 8. So we have 8 times 0.4, which gives us 3.2, and we were told this was seconds. Example 3. Let the graph of G be a horizontal shrink by a factor of 1/6, followed by a translation 3 units to the left of the graph, f of x equals the cube root of x. Write a rule for g of x. So our parent function is f of x equals the cube root of x. So our first thing is horizontal shrink. By 1/6 gives us a factor of 6. So we have g of x then starts to become the cube root of, and the 6 goes under, based on horizontal goes under, so it goes under. So we have the cube root of 6x. Part 2 is the translation, 3 units left. So it's a horizontal translation, so we have to use these. If we want it to go left, it has to be positive. It also has to be added onto the x. So we have g of x equals the cube root of 6 is our horizontal shrink. We need to add 3 to x to give our translation 3 units left. So then if we multiply the 6 or distribute the 6, that gives us 6x plus 18. Now you need to look at the agenda to determine what your assignment is out of the book.